Okay, so the last thing that we're going to look at is special product patterns. And so this is just straight from your book. There are three different types of multiplications that we're going to notice especially. One of them is the sum and difference product pattern. So if I have a plus b times a minus b, the result is a squared minus b squared. The next one is a square of a binomial. And so if I just have a plus b squared or a minus b squared, the pattern that it follows is always this right here. Notice that a plus b squared does not equal a squared plus b squared. That never happens, although it's a very, very common mistake. And then we have a cube of a binomial, a plus b cubed, right? And so there's the pattern here. And so I probably would pause this video and just write down some of these, those three product patterns, so that you remember them. And we're going to use them in the next couple examples. So the first one is 5y minus 3 and 5y plus 3. It says find the product of these binomials. Multiply these polynomials. So we already know how to do this. We did this already. We can multiply these using kind of horizontal way. We could use a vertical method. We could even put them in a box method and get the answer. And if it were me, you know, this problem would definitely be easy enough to just do it by hand and just go ahead and multiply the traditional way. But you're going to notice that on some problems, using patterns to leverage, the power of, the problem is going to be much easier to do in certain situations. So just want to get used to using and noticing these patterns. If I look at the first problem, I have something minus 3 and something plus 3. That's going to follow the sum and difference pattern. So I'm going to bring this side by side here and really just focus on using this pattern that I have to solve the problem. So here's the pattern. And what I want to try to do is just kind of map these up. So you can see this pattern is very similar to what I have. I have a plus b and a minus b, and I'm seeing the same thing here. So, this is kind of like my a plus b, and this is kind of like my a minus b. So in this problem, my a value is really kind of similar to 5y, and my b value is similar to, we could say, 3. Well, we know the answer to this is going to be a squared minus b squared. So I can sort of bypass multiplying those four things out and adding, kind of like what we did before. And I can go right to the answer, which is going to be a squared, or 5y squared minus b squared, which is going to be 3 and then squared. There's my answer. And so we can clean it up a little bit as well, because I can say 5y squared. Well, that's going to be 25y squared minus, and then 3 squared is 9. So I can get to my answer a little bit quicker by noticing these patterns. Now at first, when we're trying to map the patterns together, it's going to probably take you longer because you're thinking about what the pattern is, and you have to notice it and then map it, and it's the first time you're going through it. But as you notice the patterns more strongly, and you use them more, it becomes a little quicker. So let's try another one. All right, part B is 4a plus 7 squared. So again, I could do this traditionally by just saying, all right, let's say I forgot whatever the pattern was. I could certainly take 4a plus 7 times 4a plus 7, and I could just multiply that out. Okay, so you could always rely on just straight up multiplication and doing it the old-fashioned way. Okay, but this is a pattern. So I'm taking, this is a perfect square right here, 4a plus 7. If I go back to my patterns, that's going to be like this one. So let's go, my pattern is right here. So basically in this problem, you know, I could utilize this pattern because my a value is really 4a, and my b value is kind of like 7. So I could leverage this pattern right here and just jump straight to my answer. My answer is going to be a squared plus 2ab plus b squared. So I could jump right to my answer and say, okay, well, this is going to equal 4a squared, okay, plus 2ab, so plus 2 times my a value is like 4a, and my b value is like 7, so I'll put a 7 there, and then plus b squared. And in this case, my b value is 7 here. So you can sort of see how this right here, the a squared plus 2ab plus b squared, is now being used over here, except that my a and b values are now changed because the problem's different. My a is 4a and the b is 7. So again, here's my answer. And then, of course, I still need to do some multiplication and some exponent properties and clean up here. So let's finish it up. This 4a squared would be, 4 squared is 16, and then I'd have a squared there. Plus, now I have 2 times 4a times 7. So this right here, I could multiply all the numbers together. So 2 times 4 is 8. 8 times 7 is 56, so I could say this is 56a coming from that. And then plus, well, 7 squared is 49. So I can get to my answer, and there's my answer. Let's try another one. So here I have mn minus 6, and this is cubed. So in my opinion, this is where it starts to become really handy. Once the exponents and the multiplication become much more tedious to do by hand, I could take mn minus 6 and I could just go ahead and multiply these together. I could say this times this times this. Right? I could do that and it'd be kind of a pain. Certainly if I had like more than that, I mean, mn minus 6, let's say it's to the 5th. Like that's just gonna be a lot of work. Okay. So I could do it the old-fashioned way, but I'm really going to focus on patterns now. So let's go back to the pattern. I have something minus something, and it's cubed. So how does that work? So this one right here, where we have the cube of a binomial. So we're going to go ahead and pick out this one right here. So the pattern is right here. And you can see this is going to work here because I have something minus something cubed, just like I have over here. I have a minus b cubed. In this case, though, my a value is going to be replaced by mn. So a is going to become mn, and my b value is going to be 6. So my answer is going to be this right here, a cubed minus, you know, that whole thing, but I'm just going to substitute in mn for a and then 6 for b. So I'm going to map this out and put that away. I'm going to map this out and I'm going to write this as, let's see, a cubed, which is what I have over here, minus 3 times a squared b. I'm not going to plug in those values yet. And then plus 3 times a times b squared, and then minus b cubed. So I basically just wrote out this whole thing again, but I left spaces, these little spaces here, because my a and b are now different. So I'm going to plug in my new a value, which is, in this problem, it's mn. So I have mn cubed minus 3, and then this is mn squared. My b value is 6, so this is a 6 right here, plus 3 times a, so again, this one's mn, but times b squared, my b is 6. And then minus b cubed. Well, b again is 6. So there's my whole thing. I took that whole pattern and we just plugged in or substituted a and b in there for it. So we have our answer. We just need to multiply things and clean it up again. So mn cubed. All right, well, if we were to use some exponent properties, right, we could write mn cubed as m cubed n cubed. Okay, because that 3 right here could be applied to both terms there, or both factors there, the m and the n. And then I'm going to have a minus. Okay, so now I have 3, well, I have the 3 times 6 here. So 3 times 6, I'm going to have 18. And I have mn, and that's all squared. So very similar to what I had first. But now I'm going to have m squared n squared plus. Okay, so now I have 3 times 6 squared. So 3 times 6 squared, we could make multiple steps of this, but 6 squared is 36. And 36 times 3 is 108. So this is 108, 3 times 6 squared. And then we have mn here, so that just stays as m times n. And then I have a minus 6 cubed. Well, 6 cubed is 216, so 216 there. So it takes a little time to figure out that last step, but again, I look at the problem, see if there's any like terms that I can combine, and there's no like terms after this, so this is going to be it. This is my final answer, and that's it. All right, so if you want a practice problem for that one, you can pause the video and try this one, xy minus 4 cubed. And if you do that one, your final answer should be x cubed y cubed minus 12x squared y squared plus 48xy minus 64.